Hey everybody, today we're going to talk about day 2 of optimization, and we're going to be dealing with profit, posters, graphs, and distance, which sounds exciting, right? So here we go. Let's start with those profit questions. So we have a company that is selling a new type of smartphone. We're given the price of each of those smartphones. We're given how much the parts cost, and then the labor and overhead for running the plant, so a per day cost. And so the question is, how many smartphones should the company manufacture and sell to maximize profit? So that is our goal. So that tells me I better be able to come up with a function for profit in terms of our variable x, so that we can go ahead and work with that, differentiate, set it equal to 0, and all that good stuff. So let's think for a minute about profit. I'm going to call it P. So I know profit is really my revenue, how much I'm taking in, minus my expenses, how much I have to pay. So if I'm thinking about smartphones, right, my revenue is probably going to be the number of smartphones I sell times the price that I can sell it for. And then my expenses are going to include things like parts, like labor, stuff to run my facilities, all that good stuff. So let's see what we're given in this problem. So for profit, I know the price of my phone is 160 minus 0.1x. And then they're telling me x is the number of smartphones I'm manufacturing. So I could potentially make x times that price. That would tell me how much revenue. Now I have to subtract out all my expenses or costs. So I have parts that cost $70 per smartphone. So that's going to be 70 times x, so times the number of smartphones that I'm able to sell. And then I also have costs of 5,000, and then this is just a flat 5,000 per day. So I have my revenue here and my total expenses here. So that's going to give me a function for my profit. So I'm going to simplify. Let's see, I have 160x minus 0.1x squared minus 70x minus 5,000. And I'm just going to combine my terms, do a little rearranging. So negative 0.1x squared, 160 minus 70 is going to give me plus 90x minus 500. So there's my profit equation. And it's nice because I only have the variable x to work with. I didn't need to worry about a second equation. So now I'm just going to take my derivative. So I get negative 0.2x plus 90. That's equal to 0. So 90 equals 0.2x. And if I divide that, I get x is 450. So I'm going to maximize profit when I manufacture 450 smartphones. Okay, so you'll be working with lots of similar profit type questions. All right, our next question has a little bit to do with graphic design. Okay, so our designer is asked to create a movie poster with a 50 square inch photo surrounded by a 4-inch border at the top and bottom, and a 2-inch border on each side. So before I go too much further, I want to sketch this out. So I've got my poster in the middle. Let's see, I have a 4-inch border at the top and bottom, and then a 2-inch border on each side. And I know the dimensions of my inside here, my poster, should be 50 inches squared. So now the question is, what are the overall dimensions for the poster should the designer choose to use the least amount of paper? So I need to assign a couple variables here. So I'm going to assign X to be the height of my poster, not including the border. And I'm going to let Y be the width of my poster, again, not including the border. So I know from what they told me that X times Y, the area of that poster, is equal to 50. Now, let's see. If I want to use the least amount of paper, what I'm really talking about here is minimizing the area. So I need to come up with an equation for the area of the overall poster, including the border. So if I look, if my width of the poster was Y, and I know I have a border on each side of 2, my overall width is going to be Y plus 4. Similarly, if the height of my poster was X, and I have a border on each side of 4, my height is going to be X plus 8. So my area is going to be X plus 8 times Y plus 4. But again, what I really am looking for here is an area function just in terms of X, so that I can go ahead and do my differentiation and solve. So I'm going to use this equation to get Y by itself. I'm going to isolate Y. So Y equals, I'm going to have to divide by X, because now I can substitute that in for Y here. So I have X plus 8. Instead of Y, we're going to use our 50 over X, and then add plus 4. And so I've got a nice area equation just in terms of X. So again, I'm going to expand that. So X times 50 over X, that's just 50, plus 8 times 50 is going to give me 400 over X, plus 4X, plus 32. So now all we have left to do are the mechanics here of differentiating and solving. So a prime of X, my 50 cancels out. Here I'm going to have negative 400 over X squared plus 4. My 32 is going to cancel out there. The derivative is 0. And so I'm just going to set this equal to 0. So I get 4 is equal to 400 over X squared. So X squared is equal to 100. Now, really we would have X as positive or negative 10, but since we're talking about the dimensions of a piece of paper, that negative 10 is obviously going to be excluded. So I get X equals 10. So I'm going to use my equation here to solve for Y. So Y is 50 over X. Our X is 10, so I get a Y of 5. Now here's what we have to be careful of. They're asking us to find the overall dimensions for the poster. Right now, I just have the interior dimensions without the border. So what I need to do is take my X and plug it in here to get that overall dimension. So my height is going to be 18 inches. So 18 inches tall by, my width here is Y plus 4, so 5 plus 4 by 9 inches wide. Those give me the overall dimensions for that poster. All right, now we're going to move on to our graphs and distance, which are probably some of the trickier problems initially, although once you recognize what's being asked, they're not quite so bad. First thing I'm going to do for us here is change this problem a little. Let's change this equation to make it 16. It's just going to work out a little bit nicer so we don't get stuck in some of the mechanics here. So what we have is a geometry student wants to draw a rectangle inscribed in the ellipse x squared plus 4y squared equals 16. And we want to know what's the largest area, or the area of the largest rectangle that the student can draw. So again, here I think it's really important to draw a picture to see what we're working with. So the first challenge maybe here is to remember how we graph an ellipse. So the first thing I'm going to do here is I'm going to divide by 16 everywhere. So I'm going to get x squared over 16 plus y squared over 4 equals 1. So that's kind of our standard form. So now my a squared here is 4. Or a squared is my 16, excuse me, b squared is 4. So that's going to tell us how this ellipse is going to lie. So now I know, since my 16 is bigger, my major axis is along the x, my minor is along the y. So here's how it's going to look. Since a squared is 16, I know my a is 4. So that's going to tell me I have points here and here along the x-axis. Then b squared is 4. My b is 2, so I have a point here and here. So if I can somewhat nicely sketch this in, I have an ellipse that looks like that. So there's my ellipse. And now what's happening here is what we're doing is drawing in a rectangle, inscribing it so that the corners of my rectangle are on that ellipse. And I wanted to know what's the area of the largest rectangle that I can draw. So we're trying to maximize area. So I need a formula for the area of this rectangle. So here's what I'm going to do. I'm going to call this distance here x. And I apologize that this is so small. And then I'm going to call this distance here y. So if I really look at, I'm just going to draw this out here, my whole rectangle, if this distance is x, then the whole width of my rectangle must be 2x. And again, if this is y, the whole height of my rectangle must be 2y. So now I have an area that's 2x times 2y, or 4xy. Now I have to figure out how to get this area just in terms of x. And here's where we're going to use our algebra to rearrange this function to just isolate y. So if I have x squared plus 4y squared equals 16, I know I want to isolate y. 4y squared is going to be 16 minus x squared. Then y squared is going to give us 16 minus x squared over 4. And so y will be square root of 16 minus x squared over 4. And if I simplify that a little bit, I get 16 minus x squared all over 2. So now I have an expression for y that I can plug into my area formula. So area in terms of x is 4 times x times the square root of 16 minus x squared over 2. And so I'm going to do some quick simplification here. That 4 divided by 2, I have 2x times the square root of 16 minus x squared. So now it took a little bit of getting to there, but I have a formula for my area. Now, our process, we're back to just the same place we were before. We know we need to find the derivative and set it equal to 0. So finding the derivative might be a little more complex. I notice here that I'm going to need the product rule, but it's still the same concept. So for product rule, I'm going to take my first piece, 2x, times the derivative of my square root here. So times 1/2 times 16 minus x squared to the negative 1/2. I'm going to be very careful because I have chain rule here, so I need to multiply by a negative 2x. And then I'm going to go the other way. I'm going to take this function, the square root of 16 minus x squared, times the derivative of 2x, which is 2. So before we start solving, let's see what simplification we can do. I can cancel the 2 with the 1/2. So I'm going to have a negative 2x squared on top over the square root of 16 minus x squared. And then I have plus 2 times the square root of 16 minus x squared. And what I want to find out is where that's equal to 0. So I have 2 times the square root of 16 minus x squared. That's now equal to negative 2x squared over square root of 16 minus x squared. Oops, this will be positive because I added it to the other side. I'm going to divide each side by 2 so I can make this a little more simple. Now if I multiply by square root of 16 minus x squared, I'm just going to get 16 minus x squared, and that's equal to x squared. Add an x squared to each side. I'm going to get 16 equals 2x squared. Let's see, I'm going to go over here. Sorry, I'm kind of running out of space. Now, if I divide by 2, I get x squared is equal to 8. So x is equal to the square root of 8. Again, I'm ignoring that negative value because we're talking about length here. Now, that gives me the dimension, almost gives me the dimension of one of my sides. However, what I'm asked for is to find the area. So I'm going to plug this square root of 8 into my equation for area. So area at the square root of 8 is equal to 2 times the square root of 8 times the square root of 16 minus 2 root 8 squared. So I have 2 times the square root of 8 times the square root, let's see, 2 root 8. So 2 squared is 4. Oh, sorry. This should be minus x squared. It should just be root 8 squared. Sorry about that. Okay, so now I have 16 minus square root of 8 squared is just 8. So 16 minus 8 is just 8. So I didn't need all this. Now the square root of 8 times the square root of 8 is just 8 times 2 is 16. So we get an area of 16 units squared. That one I recognize is tricky, and I anticipate we'll spend some time tomorrow going over some of the mechanics of that problem. All right, last one for today. And again, this might be one we have to revisit tomorrow, which is okay. You'll be practicing all of these different types of problems. You'll be working with them a lot more tomorrow. So the last one says, which point on the graph of y equals square root of x is closest to the point 2, 0? So let's take a look what's going on here. My graph square root of x looks like this. And so what I want to know is if I take this point 2, 0, I want to find a point on this graph. So any point on this graph has the coordinates x square root of x. I want to know what point will really minimize the distance between those 2 points. So if I'm looking to minimize the distance, well, I know I have this thing called the distance formula that's going to come in really handy. So that's what we're going to be using for this one. So my distance formula I know is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So in our case, our distance formula in terms of x is just going to be x minus 2 squared plus, if I look at my y values, square root of x minus 0 squared. So I'm going to simplify under the radical a bit. And I'm going to get x squared minus 4x plus 4 plus, if I square the square root of x, I'm going to get x. So my function is x squared. Negative 4 plus x is a minus 3x plus 4. So now I'm going to differentiate this. So d prime of x is just going to be 1/2 times x squared minus 3x plus 4 to the negative 1/2, and then I have to multiply. I have my chain rule, so I have to multiply by the derivative of the inside, times 2x minus 3, and I'm going to set that equal to 0. So what we're really looking at is this. And we want to know where that's equal to 0. Well, I know if I have a rational expression, the only way this is going to be 0 is if the numerator is equal to 0. And that's going to happen when x equals 3/2. So now I know the x-coordinate of my point is going to be 3/2. The y value of that point is just the square root of that value, so square root of 3/2. And we're not going to worry about rationalizing. So that tells me that this point, 3/2 root 3/2, is the point that's closest to the point to 0. So I know that's a lot for today. Again, we'll have all of tomorrow for you to work in class and ask questions about these problems.